probably I can go directly to micro heat pipes, and then what you call a micro heat pipe, I will explain to you what is the construction of that, and especially we will be discussing about two designs of micro heat pipes. One called a triangular cross-section micro heat pipe, the other one a wire sandwiched or wire bonded design of micro heat pipe. I'll tell you a little bit about how to go about analyzing these systems theoretically. We have already seen some theoretical analysis of heat pipes, so I will be only talking about what is special about this mix analysis, what is different from the analysis of a conventional heat pipe members. So something about numerical modeling and some results out of that. I'll be talking about these for both designs, the triangular design as well as the wire sandwich design. Don't worry what these are, we are going to see what these designs are. A bit about experimental study which we had done in order to benchmark the results of the theoretical model that we had produced. We have to see whether we are predicting, using the theoretical model, whether we are predicting the thing correctly. So we can compare it with some experimental system. I'll talk to you about how the experimental system was made, how the heat pipe was made, how the testing facility was also made, and then how the experiments were conducted, and then comparisons done. So then I'll come back to some parametric analysis on, especially on the wire sandwich design, which is a newer design that we are still working on. One of the reasons why I decided to come and talk to you is to motivate some of you into what is research. So for this talk, actually I thought that the topic that I am using, the micro heat pipe, is a tool for me to communicate my way of looking into research, and then what can be motivational in research and what research means. Especially when you talk about systems like this, where we do research, we should have a methodology for research. It may not be sufficient that you just keep on doing some work, either experimental or theoretical. So one reason why I have taken this particular example in this particular way is also to convey to you what may be the appropriate way of going ahead with research. Like you have conceived a system, probably you have developed a system in the basic form, then I do the theoretical analysis. After doing the theoretical analysis, why do I do the theoretical analysis? I cannot do 100 experiments, is it not? So I may have to have a generic model which comes from a theoretical analysis. Then, in order to believe my theoretical results, I have to compare with an experiment, some certain special case, and then benchmark it. Then I come back to the theoretical analysis. I come back to the theoretical analysis and do parametric studies on the theoretical model. Not like keeping on doing experiments. So I verified my theoretical model, said that this is fine, then I come back to the theoretical model and then do numerical experimentation as I do, or other parametric studies. And then it's as if doing so many experiments. So I get the results of this and try to optimize the design based on results of the theoretical analysis. So this is a somewhat good philosophical procedure which you can do whatever kind of research work you do on physical systems. So I just wanted to show an example of that also here. Take this example of the micro heat pipe. I thought that this micro heat pipe example is not far away from the context of what we are listening here from the morning onwards on heat pipes. And of course it's an interesting device. It has got a lot of good applications also. That is why I was have sort of arranged the presentation contents in this particular fashion. And I'll start with some interesting research needs that we can have, probably collect from this particular aspect and then keep on working on. Because when we say that there is some problem existing, we are happy. Because scientists cannot live without problems. Like, we are happy that some problem is there for us to solve. So what will be the research needs for future, and then how we can kind of apply our knowledge or our enthusiasm in scientific research in order to solve some of these problems.